The topic for discussion is writing half equation for oxidation reaction. That is, writing half equation for reducing agent. Example 1. I want to look at the oxidation of sodium ethanedioate solution with the formula Na2C2O4, or ethanedioic acid solution with the formula H2C2O4. In the oxidation reaction, it is the ethanedioate ion, that is C2O42-, that is oxidized and is the reducing agent. Note that when ethanedioate ion, that is C2O42- ion, is oxidized, it gives effervescence of carbon 4 oxide gas. On the tutorial board is the half equation for oxidation of ethanedioate ion. In the half equation, the oxidation number of carbon in C2O42- is plus 3, while the oxidation number of carbon in CO2 is plus 4. That is, the oxidation number increases from plus 3 to plus 4. Increase in oxidation number is oxidation reaction. Therefore, C2O4 is oxidized in this reaction to give carbon 4 oxide gas. To know the number of electrons that the C2O42- will lose during this reaction, use the number of carbon atoms in C2O42- ion, that is 2 atoms of carbon, to multiply plus 3 on the left hand side of the equation, and that gives plus 6. On the right hand side of the equation, use the 2 moles in front of CO2 to multiply plus 4, and that gives us plus 8. The difference between plus 6 and plus 8 is 2. Therefore, C2O42- will lose 2 electrons during the oxidation reaction. I want to look at example 2. Example 2 involves oxidation of sulphur 4 oxide gas in aqueous medium. In the oxidation of sulphur 4 oxide gas in the presence of water, it is the sulfur of SO2 gas that is oxidized and is the reducing agent. Note that when SO2 in the presence of water is oxidized, it gives dilute H2SO4 acid solution. On the tutorial board is the half equation for oxidation of sulphur 4 oxide gas in the presence of water. In the half equation, the oxidation number of sulfur in SO2 gas is plus 4, while the oxidation number of sulfur in H2SO4 acid is plus 6. That is, the oxidation number increases from plus 4 to plus 6. Increase in oxidation number is oxidation reaction. Therefore, SO2 gas is oxidized in this reaction to give dilute H2SO4 acid. To know the number of electrons that the SO2 will lose during this oxidation reaction, the difference between plus 4 and plus 6 states in the oxidation number is 2. Therefore, SO2 gas will lose 2 electrons during the oxidation reaction. I want to look at example 3. That is the oxidation of potassium iodide solution. In the oxidation of potassium iodide solution, it is the iodide ion of potassium iodide that is oxidized and is the reducing agent. Note that the iodide ion is oxidized. Note that when iodide ion is oxidized, it gives violet vapor of iodine gas. On the tutorial board is the half equation for oxidation of iodide ion. In the half equation, the oxidation number of iodide ion is minus 1, while the oxidation number of iodine gas in free state is 0. That is, the oxidation number increases from minus 1 to 0. Increase in oxidation number is oxidation reaction. Therefore, iodide ion is oxidized in this reaction to give violet vapor iodine gas. To know the number of electrons that the iodine ion will lose during this reaction. Use 2 moles in front of the iodide ion to multiply the -1, and that gives -2. Use the 0 for the free iodine gas to multiply the 2 atoms of iodine, and that gives 0. The difference between 2 and 0 is 2. The iodide ion will lose 2 electrons during the oxidation reaction. I want to look at the last example, that is the oxidation of hydrogen sulphide gas. In the oxidation of hydrogen sulphide gas, it is the sulfur of hydrogen sulphide gas that is oxidized and is the reducing agent. Note that when sulfur of hydrogen sulphide gas is oxidized, it gives yellow deposit of sulfur. On the tutorial board is the half equation for oxidation of hydrogen sulphide gas. In the half equation, the oxidation number of sulfur in hydrogen sulphide gas is -2, while the oxidation number of sulfur in free state is 0. That is, the oxidation number increases from -2 to 0. Increase in oxidation number is oxidation reaction. Therefore, sulfur of H2S gas is oxidized in this reaction to give yellow deposit of sulfur. To know the number of electrons that the hydrogen sulphide gas will lose during the oxidation reaction, the difference between -2 and 0 gives 2. Therefore, hydrogen sulphide gas will lose 2 electrons during the oxidation reaction.